Hello, everyone, and welcome back to class. We are looking at Chapter 9 this week, Environmental and Occupational Epidemiology. So here are the key messages from the chapter. I'm not going to read through these. I would invite you to pause the recording and to read through this to kind of set the stage for what we're going to be talking about. Okay, so most diseases are either caused or influenced by environmental factors. We need to understand the ways in which specific environmental factors can interfere with health to design effective prevention programs. Environmental epidemiology. This provides a scientific basis for studying and interpreting the relationships between the environment and population health. Occupational epidemiology. This deals with environmental factors in the workplace. So there are many environmental factors that may affect health. These potential factors include psychological, biological, physical, accidental, and chemical. And examples of each of those are presented on the right. So environmental and occupational health, or environmental and occupational epidemiology, when studying this includes a large number of specific and proximate causal factors using the concepts described for hierarchies of causes that we discussed in the last screencast. The hierarchy of causes in environmental and occupational health are presented in the next slide. And so there are driving forces behind current health environmental trends. Major human activities affect environmental quality. And poor environmental quality, these are the exposures and risks that we face: air pollution, food quality, our soil, how it's changed and how it can affect the food we grow. Housing, the environments we live in, how congested things are. Our workplace environments, and the global environment. Now, what's interesting is, most of us, we're going to be wanting to look at risk factors for something like musculoskeletal injury, or look at changes in somebody post-stroke, how that affects them with their general performance of activities of daily living, how it impacts their gait, how it impacts their speech. So within our disciplines, we have specific things of interest that we look at. What increases somebody's risk? What helps to improve their outcomes? But it's important to consider all of these things because at a deeper level, this stuff may have a big impact on what our patients experience. For example, the workplace down here. I do some per diem work for a company called Concentra. Concentra does a lot of physical therapy, or provides a lot of physical therapy services for patients who have been injured on the job. So it's 100% work comp related. There are some Amazon facilities nearby where I work, and they have contracts. There are a lot of patients that I see that come from Amazon that have been hurt. Well, what is driving that? There was no Amazon at the way we think about it now 20, 30 years ago. A lot of people are working at Amazon now. It is a highly demanding job. Some of the jobs require a lot of physical effort. You've heard reports in the media about the stress that Amazon workers are under. And why are they under that stress? Because we're expecting our products to arrive within 24 hours if we order something online. We've gotten used to that. There have been changes in the environment in which we shop, and that has driven then changes within the occupational setting. So are those people at risk for injury because of a weak back or a weak rotator cuff prior to going to work there? Or are they a greater risk of injury because of the physical demands of the job that they are being forced to carry out? And I think a better example, maybe something that may get to this point a little bit better if you didn't quite catch that one, was I had a student a few years ago in this class who was a nurse, worked in a children's section of a hospital. And they noticed that a lot of people that had to come back for readmission to the hospital lived in certain zip codes. So if you did an epidemiologic study, maybe the first study would be like, oh, we find that people that come back for readmission, there is a much greater risk for readmission to the hospital if they lived in a certain zip code or zip codes around the hospital setting. But does really living, is a number something that makes you at greater risk of injury or greater risk of readmission? No, it is kind of deeper. What's in that? What are the environmental factors in that area? Is it because there is congested housing and people are able to transmit sicknesses easier or illness easier? Are these areas that are lower socioeconomic with people with lower educational attainment? And are they doing a poor job of following through with their discharge things that they're supposed to do to keep their child healthy and to reduce readmission? So it gets then that nurse to start thinking about, okay, what can we do to reduce, if we have an understanding of the demographics and the nature of the situation in those zip codes, can we start doing different things to help try to reduce the risk of somebody coming back? So that's why we study environmental or occupational epidemiology. It may be that you don't need to consider this for any type of research that you do in the future, but if you're like that nurse, maybe it is something you need to think about. The global burden of disease has shown how much environmental factors contribute to overall health. 25 to 30% of the global burden of disease may be caused by exposure to environmental factors. Major health problems that are associated with this include unsafe drinking water and sanitation, indoor air pollution due to biomass energy used for cooking and heating, and urban air pollution from motor vehicles and electric power generation. Environmental disease, the burden of it is much higher in low-income countries than in high-income countries. However, in the case of certain non-communicable diseases, such as cardiovascular disease and cancer, the per capita disease burden is larger in high-income countries. And we could potentially make some hypotheses, and maybe that's due to the fact that there are more people smoking in high-income countries. That affects both the heart and also many cancers. We might assume, too, that maybe people in the high-income countries are able to live long enough to the point where they then develop a cancer or cardiovascular disease. Now, children bear the highest death toll, with more than 4 million environmentally caused deaths yearly, and these are mostly from developing countries. Infant death rate from environmental causes is 12 times higher in low-income countries, and so there is then great potential for helping to make improvements if changes in health status are done. In epidemiologic studies of environmental factors, each factor is often analyzed in isolation. However, there are many ways in which environmental factors can influence each other's effects. Multi-causality and a clear hierarchy of causes are often evident. This may explain differences between the results of observational epi-studies conducted in different locations. How environmental factors affect an individual also depends on other risk factor exposures and individual characteristics, many of those listed on this slide. Now, occupational epidemiology is usually concerned with an adult population that is young or middle-aged and often predominantly male. In occupational epidemiology, most exposed persons are relatively healthy, at least when they start working. Now, some populations may be of specific age ranges. For example, what are typically the age ranges for those who do manually intensive work versus those who don't do that? And so that might be important whenever doing an analysis, is to make sure that you are looking at all those different factors. Although it all depends, because sometimes, work I've done with migrant farm workers, individuals that are potentially here on a temporary basis or a rotating basis, you will find individuals in their 60s working in the fields where you may not find non-migrant farm workers working manually intensive long-hour jobs when they're in their 60s. Environmental epidemiology. This explores associations between environmental factors and individuals of all age ranges, as well as individuals who are sick. Now, exposed people in the general population are likely to be more sensitive to such factors than workers in industry. This is of importance when the results of occupational epidemiology studies are used to establish safety standards for specific environmental hazards. For example, the effects of lead occur at lower exposure levels in children than in adults. So if you were just looking at lead exposure in adults, that might not be, you might miss the complete picture. And obviously then understanding how it affects children, if you got in the past that people were using lead paint and, painting a home, what, to expect an adult to be doing that as they were preparing that home for sale. But then as a family moved into that home, that exposure potentially to the lead-based paint would then have been hazardous for the child. Here is table 9.2 from your text, illustrating that in adults, the levels which lead to decreases in hemoglobin and changes in neurobehavioral function are at a much lower level in children than they would be in adults. Now, looking at evaluation of preventative measures, the main emphasis in environmental and occupational epi has been on studies of the causes of disease. Specific preventative measures to reduce exposures and the impact of occupational health services also need evaluating. Exposure to hazardous environmental factors is often the result of some industrial or agricultural activity that brings economic benefit to the community. The costs of eliminating these exposures can be considerable. So, with looking at environmental epi and occupational epi, there's that appreciation or that tension that the pollution associated with a particular occupation or a particular job, that can be costly, that can cause damage to the industrial property, that can cause damage to the agricultural land around that area, as well as individual health. When doing epidemiologic analysis, health impact assessments and cost effectiveness analyses help public health authorities to find potentially an acceptable balance between the health risks and the economic cost of prevention. So think about some of these headlines here. This Kentucky coal town is fighting for survival long after the war on coal is over. So, is using fossil fuels, using coal, detrimental to the health of a community, to the health of individuals who work in it, right? Coal miner's lung. But even though black lung disease is a concern for people working in those environments, also a concern is having a job. And I'm not advocating or making any type of political statements at this time. I'm just illustrating that there's always these tensions where, especially if something isn't quote unquote old technology, you have people that have dedicated their lives to working in that environment, and transitioning from working one type of job to another is very difficult. And so, as coal goes away, that will cause a major disruption to the lives of many people that are supported by that industry. In Mingo County, residents hope tourism will fill in the economic holes that are left by coal. How do you make those transitions? And so, again, as you see the impact of disease that's brought about by old technology, in this case, coal, how does that community survive or thrive into the future? And then, of course, I think fracking is maybe something that is maybe quote unquote newer technology, but it's also something at a political level because there are areas in the country where fracking is easier to do, but then other areas where fracking is blocked, and gets into again the way that people in those areas view that as a potential threat to environmental quality. Environmental pollution, again, is often costly in itself and again may damage agricultural land or that industrial property. And again, just to reiterate, there's this balance. Epidemiologists find that there's a health impact. There's going to be a cost analysis that's done. Public health authorities working with local political leaders will be then trying to make a determination as to what's acceptable. And it's not always what's acceptable to everybody. Let's take a look at the value of prevention now. So, examples of combined epidemiology and economic analysis demonstrate the potential value of prevention. In three quote unquote pollution diseases that occurred in the 1960s in Japan, it was calculated that prevention would have been cheaper than the cure for each of the diseases. Here's Table 9.3, pollution damage and control costs for three disease outbreaks in Japan. And so we see the pollution disease, the main pollutant, the pollution control costs, and then the pollution damage costs. And again, they found that the benefit was on the side of doing prevention, that it was going to be less costly to implement prevention strategies than to treat the diseases caused by the pollutants. Environmental epidemiology will face new challenges in the coming decades with changes in the global environment. Studies are needed of the health impacts of global climate change, depletion of the ozone layer, UV radiation, and aspects of population dynamics. And an interesting article I read just over the weekend, I read it on my phone, so I didn't keep it, but it's something you could probably Google and find. And that is they're studying viruses that are, I think it was Siberia. And with climate change, if areas thaw out, will that then allow these dormant viruses to become activated? And so if you're now getting viruses that have not been around for, I think the article said 50,000 some years, what is going to be the health impact upon society? Are these going to be viruses that are just like the common cold? Or will these lead to potentially new pandemics? And then also looking at climate related things, here was something from the Portland, Oregon area a few years ago. Portions of the West Coast got hit with this crazy heat storm. And what this is showing is the highest temperature for the prior 4 years, going back to 2021. There isn't any data here for 2022 or 2023 because I was trying to illustrate that in 2021 we hit a 114, and actually where I live we hit 118. There was like 3 or 4 days where temperatures were really, really high. I think Canada, we'll see in the next slide, hit over 120. Canada. So what happens when you've got temperatures like that? How does it affect the growing season? So a lot of grapes, berries, a lot of things grown during the summer months here. How does it affect that? How are crops affected? But we also saw an estimated greater than 100 deaths due to individuals not having air conditioning or proper cooling. So there was some excessive deaths due to heat. So again, 121 degrees in Canada at that time in 2021. So this figure here, figure 9.1, is kind of an illustration or an interaction of how climate change affects health. And so again, why are we discussing this? We are healthcare providers. We're thinking about either injury or maybe how stroke affects how we talk or how we eat, et cetera, et cetera. This is, again, just this kind of overall look at how climate change has an impact upon health. And so if you're an athletic trainer, if you're a sports physical therapist, you may be now thinking, oh, okay, well, if temperatures are now consistently in Oregon, in Portland, now often hitting above 100 degrees on certain days or certain periods of time, does that change how we structure practices? At the college level, they report in August, early August. Does that mean we need to now do a lot of indoor training to reduce heat exposure? Let's go ahead and pause the recording here, and we'll then pick up with exposure and dose in the next portion.